Today we are going to be talking about friction. Yeah. What is friction? What is friction? What is friction? Friction is simply the force that acts on the surface of separation between two bodies. Okay, that force that acts on the surface of separation between two bodies or two objects. Okay, it can also be defined as the force that opposes motion. Okay, now we are going to talk about one of the laws of friction. Can you guess? Yeah, the particular law we're going to be discussing today is that one, the law that states that friction is proportional to normal reaction. Yeah, friction is proportional to what? Normal reaction. I hope you can see me. I hope you can see what I'm doing on the board. Okay, friction is directly proportional to what? Normal reaction. Now, you know in mathematics that if we remove the sign of proportionality, we have F is equal to what? We introduce a constant. So we are introducing a constant mu. A constant mu is what? Introduced. Okay, so now we have this law. F is the friction. Mu is the coefficient of friction. R is the normal reaction. Okay, now if we have a body on a plane, okay, let's say this is a plane and now this is a box on this plane. Okay, now take note of this. The weight of this plane acts downward, while the normal reaction acts perpendicular to the plane. So if this is the plane, perpendicular means you are drawing a straight line on the plane. So we have this. So this is the normal reaction. And of course, we have what we call the, let's say we want this box to move from this position to this position, right? Okay? It's either we pull it. Yeah, we pull it. So if we are pulling it, let's call the force P. Now, of course, there will be another force opposing this motion, which is the frictional force. Okay, so we have R for normal reaction, W for weight, P for pull. Okay, it can be push or pull, but I said we are moving this body from this point to this point, so I have to pull it. If I'm to move it from here to here, I have to push it. Okay, so we have F for the frictional force. Now, I hope you understand that part. I said that the normal reaction is usually perpendicular to the plane. What if the plane is like this? I hope you can see what I'm doing. If the plane is like this, so it means the box is going to be this way, right? The weight will act downward. Then, I hope I'm not blocking you. Then we have the normal reaction perpendicular to the plane. So this will be our normal reaction, while this is the weight. I hope you are seeing. Let me wipe the old information. Okay, what we will have the plane this way. So this is the body. So the weight will still be acting downward. Since the normal reaction is what? Perpendicular to the plane. It means that the normal reaction also will be this way. I hope you understand that principle, that the normal reaction is perpendicular to the plane. Okay? So when you have a problem like this, check out and you are confused on what direction the normal reaction should be. All you need to do is just to draw a straight line on the plane, and then you have your normal reaction. Okay, so now let me go back to the former diagram that I have. You still remember the first diagram I drew? Okay, we have this. Let's say this is our box. This is the box. The weight is acting downward. The normal reaction acts perpendicular to the plane. Are you seeing? Then I say if I'm to pull this box from this point to the right hand, I need to pull it. Let's use P for our what? the force applied. Then, of course, we have another force opposing this motion. This force is what? The frictional force. Now, look at this. Let's check out one case one. Okay? I hope you are seeing. Okay? Okay, let's check out case study 1. Now, supposing I want to pull this body from this position to this position. All right? Are you following? If I want to push, okay, let's start with the simplest. Okay? Now, I'm pulling this box. I want to push this body from this position to this position, and I'm pulling, but the body refuses to move. I pull, the body refuses to move. What does that mean? Do you know? It means that there is no acceleration. So it means the acceleration will be equal to 0. Yeah. So now let's do this. So first of all, we have to what? Find the what? The force here. Okay? So now, if it is expected, that this force I told you I want this body to move from here to here. So it means that this force must be greater than this force. So mathematically, we can express this as remember, we are still talking about case 1. This is case 1, okay? So it means that this must be greater than this. So we have P minus F is equal to MA. I hope you are not wondering where MA. Yeah, from the first law, you know, F is equal to MA. Okay? So, but when it comes to the, we have to what? Do the what? The addition. And then we have this. So the force is not just one force acting on this, but it's 2. So we have P minus F is equal to what? MA. Now, like I said before, I'm pulling this box, and this box is not moving. It means there's no acceleration. And if there's no acceleration, it means A is equal to 0. So what does that mean? We have what? P minus F is equal to what? M times 0. So if you have, P minus F is equal to M. So we have P minus F is equal to what? 0. So it means that we have P is equal to what? F. Do you still remember this? You remember this? But F is equal to what? UR. So if we substitute this, we have what? UR. So for our first case study, P. I hope you are seeing what I'm doing beneath. No, you're not seeing. Let me take it up to the other side, okay? So we have been able to get P minus F is equal to 0, capital letter F, okay? So if we take PF to the other side, we have P is equal to F. I said F is equal to mu R, so we have mu R, and then we come down to this, P is equal to what? Mu R, okay? Remember, I said for the first case study, it means I'm pulling the body, but the body is refusing to move, and there's no acceleration. And then we have this. P is equal to what? Mu R. I hope you still remember what P is. P is what? The applied force. U is coefficient of friction, and R is the what? The normal reaction. So let's check out the second case study. So now the second case study we're going to be looking at. Okay. Case 2. Now, in this second case study we're going to be looking at, okay? Now, I'm pulling the body. Now, the body is coming to me. Okay, it's obeying the force I'm applying. I'm pulling and it is coming. Are you here? So, here in this case, so we have P minus F. Are you seeing? Is equal to what? MA. Okay, but we know that F is equal to UR. Okay, but before we do that, we have P is equal to, if you take this one to this other side, it becomes a plus. So we have F plus what? MA. I hope you are seeing me. So if we substitute F is equal to UR, we have P is equal to what? UR plus what? MA. But our R, I hope you remember that part. W is equal to mg. Okay, this is weight and this is normal reaction R. Okay, W is equal to what? Mg. Okay, at equilibrium, R also is equal to what? Mg. Are you following? So now if we substitute this mg here, we have what? P is equal to what? Umg plus what? Ma. So we have P is equal to, M is common. Are you seeing me? Oh, let me take it up. Sorry. We have what? P is equal to mu. Sorry, it's mu, not you. Mu. Mg plus what? Ma. What is common? M is common. So we have P, capital letter P, is equal to what? M into what? Mu G plus what? A. Now we have our what? P. I hope you still remember everything we've talked about. You remember the initials, right? Let me still go over it again, okay? So we have our what? P to be what? The applied force. The F is what? The frictional force. The R is what? The normal reaction. And W is what? The weight. I hope you enjoyed today's class. If you did, please comment, share, like. Yeah, thank you for watching. I'm still Bukola Joseph.